Hello, and welcome to Backer Breaks It Down. In this episode, we look at CPCTC and proofs. Okay, so we're still going to be working with congruent triangles and using our triangle congruence theorem. So side, 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 angle, 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 side, and HL, hypotenuse leg, to prove triangle congruency. And then from there, we're going to use CPCTC. Okay, so just a little reminder of how we go about proving two triangles are congruent. We always want to start with the given information. If it's a congruence given, mark your diagram, make a little side notation, A for congruent angles, S for congruent sides. Any other given information, we do want to draw a conclusion. After you've done this, do you have three congruences? If you don't, look for shared sides and vertical angles. Once you do have your three congruences, you are ready to prove the two triangles are congruent. Be careful. If you know of two pairs of corresponding congruent angles and one pair of corresponding congruent sides, is it angle, side, angle, or is it angle, angle, side? Likewise, if you know of two pairs of corresponding congruent sides and one pair of corresponding congruent angles, is it side, angle, side, or is it HL? So this is where marking our diagram is really going to help us determine that. Okay, so take a look here. So triangle DEF is congruent to triangle ABC by angle, side, angle. Is angle A congruent to angle D? Is segment DF congruent to segment AC? Well, if you're thinking, yeah, because the two triangles are congruent, then you're right. Because remember, when we say that two triangles are congruent, we're saying that all six pairs of corresponding angles and sides are congruent. We only need three of them to prove congruence. Okay, only three are needed to prove, but that then means that all six pairs of corresponding sides and angles are congruent. So yes, angle A would be congruent to angle D. And yes, DF would be congruent to AC. And we could also say that DE is congruent to AB. Because if two triangles are congruent, then all six pairs of corresponding parts are congruent. So this brings us to CPCTC, which stands for corresponding parts of congruent triangles are congruent. So if two triangles are congruent, then each part of one triangle is congruent to the corresponding part of the other. So in order to use CPCTC in a proof, you need to identify which two triangles should you prove are congruent. Okay, prove them to be congruent, and then you can state that the whatever pair of segments or pair of angles are congruent by CPCTC. Okay, so let's check out this in action. So here in problem 1, we are given that segments KH and JG bisect each other. Okay, and we ultimately want to prove that segment KG is congruent to segment HJ. So do you see which two triangles we should prove are congruent? So if you're thinking we should prove that this triangle KMG is congruent to this triangle HMJ, I agree with you. Okay, so let's do that. So we start with our given information. We've only been given one thing, we write it down. It's a vocabulary given, so we have to draw a conclusion. Now they say that these two segments bisect each other. So what can we conclude? Yeah, we can conclude that the segment KM is congruent to HM and that GM is congruent to JM. Okay, so I'm going to do that in two separate steps. So I'm going to say a pair of sides here in step 2, and I'm going to say KM is congruent to HM, and then in another step, I'm going to say GM is congruent to JM. My reason for both of these is the definition of bisects. So we've gone through all the given information, and we have 2 congruences, but we need 3. So we go to our look fors. We're going to look for shared sides and vertical angles. Yeah, right? So we do have a pair of vertical angles right here. So remember, whenever we're using vertical angles, we must first identify them. So I'm going to say that angle KMG and angle HMJ are vertical angles. And my reason for that is assumed from diagram. And then I'm going to immediately follow that up with that they're congruent. Because vertical angles are congruent. So now I've got my 3 congruences. I am ready to prove my 2 triangles are congruent. So, right. So I'm going to say that triangle KMG is congruent to triangle HMJ. And according to my side notations, I've got 2 sides and an angle. And so when I look at my diagram, this would be side, angle, side. Now we just have one additional step today because we are trying to prove that the segments KG and HJ are congruent. So my question to you is, are these segments, love this, are these segments corresponding parts of our 2 congruent triangles? Yes, they are. So I can say that KG is congruent to segment HJ by CPCTC. Corresponding parts of congruent triangles are congruent. So that's CPCTC. So once again, it stands for corresponding parts of congruent triangles are congruent. So once you have proven 2 triangles to be congruent, you can use CPCTC to prove that another pair of corresponding sides or another pair of corresponding angles are congruent. And that's how Becker breaks it down.